Along with adding and subtracting, we have what we call complex fractions, and we're going to simplify them in this lesson. A complex fraction is a fraction that contains a fraction in its numerator or denominator. Pretty much a complex fraction is a fraction within a fraction. It can be simplified in two different methods. The two different methods that you see are listed below. So method number one, you would simplify the numerator and denominator by writing it as a single fraction. So essentially you just add and subtract to the numerator, add or subtract to the denominator, and then you divide the two fractions. Method number two is the method that I prefer. It's when you multiply every single fraction in the entire complex fraction by the LCD, or the least common denominator. I will show you both methods to begin with, and then again, since I prefer method number two, I will probably continue on with method number two. Now again, that doesn't mean you can't do method number one. It just means that when I do problems, I will probably use method number two. So number 7, it starts out fairly simple and it's pretty basic, where you have 2/3 divided by 5/6. And what we're going to do is, now I know that you could probably just type this in your calculator and do that, but that's not what the point of this is. I want to know, again, method number one, there is no fractions that you have to add or subtract in the numerator, add or subtract in the denominator. So in this case, method number one, which I'm just going to write as M1, is where you would take your numerator, 2/3, and divide it by the denominator, which is 5/6. Now remember, when we divide fractions, that means that we keep the first fraction the same. We'll change it to multiplication, and then we take the reciprocal of the fraction that's after the division sign. So that would be the 6/5. Now at this point you can either simplify and then multiply straight across, or multiply straight across then simplify. I prefer to simplify my fractions first. So for example, I see that I can divide 6 by 3. So I'm going to divide 6 by 3, and that will give me a 2/1. And now multiplying straight across, we have 2 times 2, so that'll be a 4 in the numerator. And in the denominator, I have this 1 times 5, which is 5. So that's method number one. Method number two, again, my preferred method. I'm going to go back up here to the original problem. In method number two, you take a look at your denominators, and we have a denominator of 3 and a denominator of 6. So what I'm going to do is find the least common denominator of those two fractions. The least common denominator would be 6. So I'm going to multiply this top fraction by 6 and the bottom fraction by 6. Now remember that, not that you have to write this, but remember you are multiplying it by 6/1. So make sure that you don't multiply the denominator. Again, I prefer to simplify my fractions first. So up here in the numerator, I see that I have a 6 and I have a 3 in that denominator. So I'm going to divide out 6 by 3. So 6 divided by 3 is 2. And then I'm going to multiply 2 times 2, which is just 4. And then in the denominator, I have 6 and 6. So when I divide those, 6 divided by 6, I'm just going to get 1. And then I can multiply 5 times 1, which is 5. And you'll notice that that is the same answer that we got from method number one. So we have the 4/5 from method number one, 4/5 from method number two. Now the biggest problem that you may have with complex fractions is you try to extend this idea of least common denominators, clearing out the denominators when you add and subtract, and then you miss your denominators when you're adding and subtracting just fractions. So make sure that when you're adding and subtracting, you don't cancel out your denominators. In number 8. So number 8, my least common denominator is x plus 3, because I have an x plus 3 here in that denominator, and the bottom fraction has an x plus 3. So that becomes my least common denominator. So I'm going to do this first one by method number 2. So I'm going to multiply the top fraction by x plus 3. And I'll multiply this bottom fraction by x plus 3. So that cancels out the x plus 3. Remember, if you have x plus 3 divided by x plus 3, that just equals 1. So that just leaves me this x plus 1 in the numerator. And in the denominator, we have this x plus 3 again, and the x plus 3 in the denominator. So again, they cancel out to give you 1, and you're just left with an x. So that would be method number 2. Now, if you choose, you can choose method number 1, which I'm going to do now. So again, since I don't have to combine fractions in the numerator and the denominator, I can just use that idea of dividing by reciprocal. So I'm going to write the first fraction that we have in the numerator, x plus 1 divided by x plus 3. And we're going to divide it by x divided by x plus 3. So essentially I just took this first fraction, divided it by the bottom fraction. So when we divide fractions, we multiply by reciprocals. So I'm going to change the division to multiplication. And I'm going to take the reciprocal of this fraction here on the right. So that reciprocal would be x plus 3 over x. And now it just becomes one of those multiplying fractions, rational equations back when we did a couple lessons ago. So here I have an x plus 3 in the numerator, divide out the common factor in the denominator, and that leaves us a final answer. Here in the numerator we have an x plus 1 and an x in the denominator, which is again the same answer that we got when we did method number 2. Number 4, or number 9. Number 9 has just a 3 in the numerator, which is technically 3 divided by 1. So if you need to put a 3 divided by 1 there to understand that that denominator is 1. So we have a 1 here and we have an x minus 2. So their least common denominator would just be x minus 2. So I'm going to multiply the top fraction by x minus 2 and the bottom fraction by x minus 2. This is again method number 2. Now in the top fraction we have this x minus 2, and when you divide that by 1, which is the denominator of the 3, nothing cancels out. So we will still have 3 times x minus 2 in the numerator. And in the denominator, that lower fraction, you have your x minus 2 divided by the x minus 2. So at this point they will cancel out, just leaving you the 6. And then the last step, I notice I have a 3 as a factor and 6 in the denominator. I can simplify that to 1/2 for a final answer of x minus 2 divided by 2. Again, that was method number 2. For method number 1, I'm going to again do that same thing that we've been doing. So I'm going to take the top fraction, which is 3 divided by 1, and divide it by the bottom fraction. And then I'll change my division to multiplication, and I'll take the reciprocal of the fraction after the division sign. And again, also at this point, I prefer to simplify my common factors at this point. So you have a 3 and we have the 6, so I can cancel out. They have a common factor of 3. So when I divide that, you get 1/2. And that leaves you a final answer of x minus 2 in the numerator and the 1 times the 2 in the denominator. So again, I had this 1 and the x minus 2. When I multiplied those, you get x minus 2. And then in the denominator, the 1 times 2 became the 2. For number 10 here, we have this fraction in the numerator that we're going to have to combine. So if we use method number 1, method number 1 essentially is just adding these fractions like you did in the last lesson, and then adding the bottom fractions like we did in the last section, and then dividing them like you did in the section before the adding and subtracting. So we have a couple different options here. So again, I'm going to do method number 1 first. So method number 1 is getting a common denominator, so I'm going to take a look at these fractions up here, and their common denominator would be 10. So when we have that, we will have, let's see, I'll have to multiply the 4/5 by 2 over 2 because I need that 10, and I'll need to multiply the x over 2 by 5 divided by 5 in order to add those fractions, so that would make it an 8 plus 5x. And then here in the denominator, the bottom lower fractions, their common denominator, remember this is x divided by 1, their common denominator is also 10, because this is a 10 and that's a 1, common denominator 10. So this one on the far left, I'll have to multiply by 1 over 1, 1 divided by 1. And x over 1, I'm going to have to multiply by 10 divided by 10. So when I add those fractions, you will have 3 plus 10x. So now when I divide my fractions, we'll have our top fraction, 8 plus 5x, divided by 10, divided by 3 plus 10x, divided by 10. And then you have to change it to multiplication. So that would become 8 plus 5x divided by 10 times 10 divided by 3 plus 10x. And at this point we have our common factors. We can cancel the 10s. 10 divided by 10 is just 1. And multiplying straight across, we don't have any other common factors, so when I multiply straight across, you'll just have 8 plus 5x in the numerator. And in the denominator, we'll have 1 times 3 plus 10x. So we'll have in the numerator 8 plus 5x, and in the denominator 3 plus 10x. You cannot simplify any further. It's very tempting to simplify the 5 and the 10 because 5 and 10 have a common factor. However, you may not divide out the 5 because they are add-ins. They're being added together with an 8 in the top, and 10 is being added to 3. Remember, you can only simplify common factors. These are not factors because they're being added together. I'm going to go ahead and do method number 2 now, so I'm going to delete what I have here, so make sure that you have a good copy of it, or rewind. But I'm going to do method number 2 now, using it to figure out the same answer. For method number 2, again, we take a look at, in this case, all of our denominators combined. So we have the 5, the 2, the 10, and that 1 that's underneath of the x. And we find the common denominator, the least common denominator, of all 4 of them combined. So between 5, 2, 10, and 1, their least common denominator would happen to be 10. So what I'm going to do is I'm going to go ahead and multiply all these fractions by 10. Don't forget to multiply the x by 10. And I'm going to essentially just simplify each of these fractions. So again, just keep in mind that I'm going to divide my 10 by 5 first. So 10 divided by 5 will give me 2. And then I have 2 times 4. 2 times 4 is 8. So I just wrote that down off to the side. And then in the second fraction, my 10 can be divided by 2. 10 divided by 2 is 5. And then I'm going to multiply x times 5, which is just 5x. In the denominator, you have the 10 divided by 10, which is just 1. And then 1 times 3 is 3. And in the last fraction, 10 divided by 1 is just 10. But then I have to multiply that by the x, so that's just 10x. So that gives you the same answer that we got when we did method number 1, just a little bit shorter of a path to get there. For number 11, I'm going to go ahead and just stick with method number 2. If you would prefer to do method number 1, of course, go ahead and try it and come back and see if you get the same answer, because essentially you should. If you are going to do method number 1, you're going to have to get a common denominator of x plus 4 in the top fraction and a common denominator of x plus 4 in the lower denominator. And then you'll have to divide the two fractions, multiply by the reciprocal. So I'm going to go ahead and do method number 2. And method number 2 is to take a look at all of our denominators. So we have this x plus 4. We have the denominator of 1 underneath the 2. We have another x plus 4. And then we have 1 divided by 1. So of all of our common denominators, our least common denominator is x plus 4. So I'm going to multiply each of my fractions by x plus 4. Now, one problem that I've noticed over the years is that students tend to be a little bit sloppy when they write this least common denominator, and instead of putting the x plus 4 in the numerator, meaning multiplying it by the 4, a lot of times students will write the x plus 4 and they'll put it underneath, right next to the other x plus 4, and then they're not quite sure what to do. So make sure that when you have this x plus 4, it's err on the side of putting it too far up. So don't try to put the least common denominator next to the denominator. You want it next to the numerator. So let's go ahead and in this first top left fraction, you have the x minus 4 and the x minus 4 in that denominator. So they, in fact, eliminate one another because you have something divided by itself. And that just leaves us a 4. And in this next fraction, we have the x minus or x plus 4, and we have dividing that by 1, so nothing cancels out. So we'll have plus 2 times x plus 4. And that will give us our top fraction. And in the lower left fraction, again, the x plus 4 divided by x plus 4 will simplify out, leaving us just 5 minus. And then in the lower right fraction, x plus 4 divided by 1, nothing simplifies. So you have negative 1 times x plus 4. Now we do have to simplify this further by clearing our parentheses. So you have 4 plus, we have to distribute the 2, 2x plus 8. And in the denominator, I'll have to distribute the negative 1. 5 minus x minus 4. And then I'm going to go ahead and combine my like terms. I have 2x plus 12 divided by negative x plus 1 for your final answer. For number 12, essentially we have this right-hand side of this equation. We have a complex fraction, so we're asked to simplify it. So again, in the numerator, it's 1 divided by 1, so that denominator is 1. We have a denominator that's p and a denominator that's q. So your least common denominator would be p times q. So I'm going to multiply all of my fractions by p times q. Again, make sure that you put the p times q in the numerators next to the numerators, not denominators. And then we'll see what simplifies. So in this very top fraction, which is just a 1, you'll just have 1 times p times q, which is just p times q. And in the lower left fraction, we have p times q and a p in that denominator, so we can cancel out the common factor of p. And that will leave you a q times 1, which is just q. And then in the next fraction, the lower right fraction, we have a p times q divided by q, so my q's have the common factor. And that'll just leave me 1 times p, which is just p. And that's as far as you can go. Again, I'm going to write that as equals f, since the original problem had an equation. I'm just going to keep it equal to f. So that would be your final answer. For number 13, we have a common denominator, least common denominator of r sub 1 and r sub 2. So these are subscripts, so they are different denominators. So when we multiply through by our least common denominator, you'll have in the top, you'll have r times 1, r times 2, r1 and r2, r1, r2. So every single fraction got multiplied by r1 and r2. And then we're going to just see what we can simplify. So in the top fraction, nothing will simplify. So you'll have 2d times r1 times r2 divided by, and the lower left fraction here, we have r sub 1, and then we have an r sub 1, so that's our common factor that will be simplified. And that will leave you with r2 times d plus, and then in the lower right fraction, our common factor that cancels out is r2 divided by the r2. And that will leave you with r1 times d. Now we just do have another section here in the lower fraction. We have a greatest common factor of d. So I'm going to factor out that that common factor, GCF. In the numerator, I'm going to just keep it the same because I'm not going to factor. But in the denominator, I'm going to factor out the d, and that will leave you r2 plus r1. The reason that I knew that to think ahead is I had already seen that there was a d in the numerator, and I noticed that both of the terms in the denominator had a d. So I knew I needed to factor it out so I can cancel out the common factors. So now that I've factored it out, the d can be simplified. So we have left in the numerator 2 times r1, r2, and in the denominator r2 plus r1. And that would be your final answer. And the last problem here is number 14. And we want to find our least common denominator. So thankfully, all of these denominators are factored. There is really nothing to factor. Remember, if you had a trinomial in the denominator of one of them, like an x squared minus 3x minus 4, you would need to make sure that you factor it first before you actually try to find the least common denominator. So always factor first, then find your least common denominator. In this case, I don't need to because I just have linear factors. So you have an x minus 5, an x, and an x minus 5. So we have 4 fractions. Of those 4 fractions, their least common denominator would be an x times x minus 5. So I'm going to multiply each of these fractions by x times x minus 5. I do recommend that you write the x and the x minus 5 next to each of the fractions. If you try to just write it once, a lot of times you forget which one you canceled out. So I do recommend that you write them each time. So in the top left fraction, the one with the 6, we have this x and x minus 5, and underneath the 6 you have an x minus 5. So we have a common factor of x minus 5. So that's what simplifies in that top left fraction. And that just leaves us an x and the 6, which is 6x. In the top right fraction, their greatest common factor is an x. And that leaves behind the 1 times x minus 5. In the bottom left fraction, the x cancels out, the common factor. And that will leave you the x minus 5 times 3. In the bottom right fraction, the x minus 5 is your common factor. And that will leave you minus 2 times x. I'm going to go ahead and simplify my fractions here, or my numerator and denominator. So I'm going to distribute. There's really nothing to distribute in the top because you're just multiplying it by 1. So you'll just have x minus 5, well, 6x plus x minus 5. And in that lower fraction, or the denominator here, you'll have 3x minus 15 minus 2x. And the last step is just to combine my like terms. So we'll have 7x minus 5 divided by 1x minus 15. When we solve rational equations, there are also two methods to solve rational equations, just like when we talked about complex fractions. They are exactly the same two methods. So for this method, you can, now it doesn't really apply for this first problem because you already have just one fraction and another fraction, so this is what we call a proportion, if you remember from geometry, when you have a fraction equals a fraction. Now in number 2, we have x, 5 divided by x plus 7/4. You could, if you wanted to, add your fractions on the left and then cross multiply. So that's essentially what method number 2 would look like. I'm going to go ahead and I'm going to use that same idea that we used in complex fractions by finding a least common denominator. Now for this one, in number 1, when you have just a proportion, you can simply cross multiply. So I'm going to cross multiply and have 3 times 4x plus 5. And I'm going to multiply the 9 times x plus 1. Remember, you can only cross multiply if you have an equation and if you have a proportion. So you can't cross multiply if you don't have an equation, and you can't cross multiply if you have more than one term on either side. So I'm going to distribute. So we have 12x plus 15, 9x plus 9, and I'll just solve for x. So I'm going to subtract 9 from 12, and I'm going to subtract 15 from 9. And that'll leave me an x value of -2. Now keep in mind that we talked about extraneous solutions back in Unit 3 when we talked about solving rational equations. So you also will have extraneous solutions possible in this case as well. So remember, you always have to take your x value that you came up with and plug it back into the equation and make sure that you have a true equation. Now, I've already checked for my extraneous solutions, so -2 is not an extraneous solution, so it would be our solution here. For number 2, again, I'm going to use the idea of figuring out the least common denominator. So if I look at my denominators of all of my fractions, you have x, 4, and x. So their least common denominator would be 4x. So I'm going to multiply every single fraction by 4x. Again, I always put it up a little bit higher just so I know that that was there, and I definitely know it was in the numerator. So in my first fraction, I have a common factor of x, so that will simplify. And that'll leave me just 4 times 5. In the second fraction, our common factor that simplifies out is 4. And that leaves me 7 times x. And in the far right fraction, after the equal sign, the greatest common, or the factor that cancels out, is your x. And that will leave me -9 times 4, which is -36. I'll go ahead and solve this equation for x. So we have 7x equals -56. So our x value is -8. And that one was not extraneous. For number 3, a lot of times people forget that there is a fraction over here, 1 divided by 1. So when we multiply through by our least common denominator, you do have to multiply it through by this first fraction as well. So we have a 1, an x minus 5, and an x. So your least common denominator here would be an x and an x minus 5. So I'll multiply that by every fraction. In the top left, or the far left fraction, we have an x and an x minus 5, and we just have a 1 in the denominator. So there is not a common factor other than 1 that will cancel out. So that would just leave you the 1 times x minus 5, which I'll multiply out in a moment. In the center fraction, our common factor is the x minus 5. And that will leave us the 8 times x. And on the far right side of this equation, the common factor that cancels is the x. And that leaves you 3 times x minus 5. I'll go ahead and distribute so I can solve. So we'll have an x squared minus 5x minus 8x. And that's equal to 3x minus 15. Now, I have a quadratic here, so I don't want to get my x's on one side because when you have a quadratic, you want it set equal to 0, so you can either factor or use your quadratic formula. So when I set this equal to 0, that'll give me an x squared minus 16x plus 15. Now what I did there was when I combined these like terms, that gave me a negative 13, and then I subtracted the 3 that was on the right side. I subtracted that over, so you had the negative 13 minus the 3 to get me negative 16. That can be factored. So that's x minus 15 times x minus 1. So our x values are x equals 15 and x equals 1. Now again, don't forget that you need to make sure that they're not extraneous. So you would plug each of these in separately and make sure that you get an equation that's equal. This one, they both did work out, so neither of them were extraneous. Number 4. Now before we move on to number 4, before we actually get this completed, we have here in the center a quadratic that I need to factor. Remember, before you find your least common denominator, you must factor anything that you possibly can in the denominator. So I'm going to go ahead and keep the left fraction the same because that's already a linear factor. But here in the center, that x squared minus 9, I would factor into x plus 3 and x minus 3. And then the far right fraction is already a linear factor, so that does not need to be factored at all. So here we have an x minus 3, an x plus 3, and an x minus 3, and an x plus 3. So my least common denominator that I'm going to multiply everything through by would be x plus 3 and x minus 3. And then I'll go through and I'll see what can cancel out. So in the far left fraction, our common factor that will simplify out will be x minus 3. Now a good way to know whether or not you picked the correct least common denominator is if nothing in the numerator cancels out with something in the denominator, then you've picked the wrong least common denominator. Your denominators should cancel out. So if I forgot to put an x minus 3 here, nothing would cancel out with the denominator. You have to go back. That has to be part of your denominator. So that leaves me on the far left a 6 times x plus 3. In my middle fraction, we have x plus 3 and x minus 3. And then in the denominator, we have x plus 3 and x minus 3. So they actually cancel both of them out, just leaving you 8x squared. And in the far right fraction, the x minus or the x plus 3's cancel out, leaving you 4x times x minus 3. I'm going to multiply out my parentheses. So you have a 6x plus 18, and then 8x squared minus 4x squared plus 12x. And again, I have a quadratic, so I'm going to have to move everything to one side. So since all my quadratic terms are on the right, I'm going to have my 0 on the left. So I'm going to move everything over. So that will leave me a 4x squared and a 6x and a negative 18. There is a greatest common factor. Remember, when we factor, we always want to factor out the GCF first. So there's a GCF of 2. And that leaves 2x squared plus 3x minus 9. So we have 2x minus 3 when we factor it times x plus 3. And that will give us our x values of 3/2. And x equals negative 3. Now this one does have an extraneous solution. I know that just by a quick glance I can tell you that negative 3 has to be extraneous. If I look back up into my original equation, if I were to put a negative 3 in this fraction right here off to the far right, negative 3 plus 3 will give you a 0, and you should know that you can't have a 0 in the denominator of any fraction. It makes it undefined. So I know that negative 3 has to be extraneous just from inspection. So this one is extraneous. And that will leave just 3/2. Now I have already checked to see if 3/2 is extraneous, and it is not. So if you need to, you can also check that back into the equation. And in this last problem, it says from 1995 through 2003, the annual sales S in billions of dollars of entertainment software can be modeled by the equation that's below, where T is the number of years since 1995, so that's going to be our initial time, for which the year where the total sales were 5.3 billion. So they're giving us the S value here. So they're giving us the sales, which is right here. So I'm going to plug in 5.3 in for S of T. Now they are telling us that this only applies for times between 0, so the initial time in 1995, and 8 years from 2000 or from 1995. So this formula is only good between 1995 and 2003. So now, since I have an equation, you can either find the least common denominator, but this one we can cross multiply because you have a proportion. You just have a fraction equals a fraction. So I'm going to just cross multiply. So when you cross multiply here, you'll get 609.5 t squared. That was 5.3 times 115 plus 5,300. That was 5.3 times 1,000. And that'll be equal to 848 t squared plus 3,220. Now this does not have a linear factor or a linear term in it, it just has t squared. So I'm just going to get my t squareds on one side so I can solve using the square root method. So my higher t squared is 848. So I'm going to take 609.5 and subtract it from 848, and that gives you 238.5 t squared. And I'm going to take 3,220 and subtract it from 5,300, and that's 2,080. I'll divide both sides by 238.5. and you get t squared equals, and you end up with 8.72. And we take the square root of that. So when you take the square root of that, you get t equals, now remember when you take a square root, you have plus or minus 2.95. Now the time in this one for your final answer, we cannot include the negative 2.95 because in the original domain we only wanted times between 0 and 8. So we don't include the negative 2.95. So 2.95 is your time. But it did ask us which year were the sales total. So that's about 3 years from 1995. So that would be 1998 would be the year where the sales totaled 5.3 billion.